and it's natural logarithms. Write down the definition for a natural logarithm. If log base e of y equals x, then ln of y equals x. So basically a natural log is a regular log with a base of e. And we've already done
Is that the
logarithm.
same e that we did earlier?
Yes, same e. So whenever you see ln, you should think e automatically. Whenever you see e, you should think that we're going to use ln at some point. Alright, so everybody understand the definition? The first example tells you to condense 3 natural log 6 minus natural log 8. Natural logarithms have the same 3 properties that we did with regular logarithms. You got the power property, the product property, and the quotient property. So in this problem, the first thing I did, if I have a number, if I'm condensing, if I have a number in front, where does it go? It goes up to be an exponent, right?
Yeah.
So 3 ln 6 simplifies to ln 216 because 6 cubed is 216. What's wrong? I brought the 3 up here. So we have 6 to the third, which is 216. Okay? Minus ln 8. What goes with subtraction? Division. So when I divide 216 by 8, I get 27. Don't subtract these numbers, divide them. And there's your final answer, ln 27. Okay? So that's just using the same 3 properties that we've used before.
So the definition of those two, the 2 equations are just saying the same thing?
Yeah.
Okay.
If you have natural log, it's a regular log with a base of e. Good? Okay, solving a natural log equation. What I would do here is, we've got natural log of 3x plus 5 squared equals 4. What I would do here is change the natural log to a regular log, which means I just replace the ln with log base e. Okay, using my definition. Now, you got to be careful here. You don't want to bring this, you don't want to use your power property here and bring the 2 in front. Whenever you solve these equations, you have to condense logarithms. You can't expand it. When you bring that 2 out using the power property, you're expanding. So don't bring the exponent out, because we'll miss one of the answers. So in this case, all I did was change this to log base e, and then put it in exponential form, which is e to the 4th equals 3x plus 5 squared. Right? Okay, now we can solve. How do you get rid of a square? Square root both sides. So when I square root the right side, I'm just left with 3x plus 5 because they cancel out. When I square root the left side, I get plus minus e squared. And make sure you give me the plus minus. Remember, when you take square roots and you're solving equations, it's plus minus. Then I changed the e squared to 7.389. The further you take this out, the better, the more accurate of an answer you get. If you want to leave e squared until the very end, you can do that. But the next thing I did was subtract 5. That's where I got this from. And then I divided both sides by 3 to get my 2 possible answers right here. Does that make sense?
Do you have to do the squiggly lines when you're writing equals?
Well, this is approximate. Squiggly is approximate.
Correct.
So, yes, get in that habit of writing the squiggly lines for approximate.
Wait, why are there 2 answers?
Because when you took square root right here, you had to do plus minus.
Oh, okay.
Does that make sense? And it tells you to check your answers. Here we're okay. Both of them end up working when you plug them back in. Alright? Good?
If you were to plug in and check your answers, would you do the square root or the e? Never mind.
I would just use the decimal, and if you're anywhere in the ballpark, then it works. Okay? You'd have to be way off base for it not to work. All right, this one. Okay, let's go back for a second. In this problem, again, you saw natural log, so you should have been thinking, I'm going to use E at some point, which we did. Over here, I'm seeing E, so you should be thinking, I'm going to use natural log at some point, which we do. So the first step here to get x by itself is to subtract 2.5. So I get 17.5. Get E by itself, divide by 7. E to the 2x equals 2.5. I'll stop there while you catch up. Is everybody okay up to that point? E to the 2x equals 2.5. Do I have any questions up to here? Okay. Now, just like we did last night, when I get an equation like this, I put a natural log in front of both sides. Here, since it's E, I'm going to put or last night we just put regular log, right? Since we have E, we're going to put a natural log in front of both sides. So using the power property here, where's the 2x go? To the front. 2x ln E equals ln 2.5. And if you want to check this, but this is one of your properties, you can type it into your calculator, ln of E. Somebody tell me what you get when you type in ln E. 1. That's one of your properties. The natural log of E is always 1. So on this side, or even at this point, you should be able to tell me that this side right here simplifies to 2x, because the natural log of E is 1. 2x times 1 is 2x. So on this side, this stays natural log of 2.5. And then what do I do to both sides? Divide by 2. And your answer is approximately 0.458. Question. Okay. And the last one. Can I change the screen? All right, back to this formula, per continuous interest. Here's the formula, A equals PE to the RT. They give you your balance of $149.18. They tell you started with $100. They tell you you had an interest rate of 8%, which is very good, right? If you have anywhere you can put your money and earn 8%, you're doing really well. Now you got to find out how long it took to get from $100 to $149.18. So we just plug it straight into the formula. Balance 149.18 equals 100E, and the rate is what? 0.08 as a decimal times T. So this is what you should get in your first step. So all we're doing is plugging numbers in. Question. So now we solve this just like we solved the last one. I see E, so at some point I should be thinking natural log. Get rid of the 100 by dividing both sides by 100. This simplifies to 1.4918 equals E to the 0.08t. And at this point, put a natural log in front of both sides. And on the right side, you should be able to figure that out. What is it? 0.08t, because this is 1, remember? You bring the power in the front times 1 is just whatever the power is. And the left side stays the same. Then just divide both sides by 0.08. You get what you could have done, but you need to be careful. You could have typed this into your calculator and then divided by 0.08, or I would just type it straight in like this, the whole thing at one time, so you don't have to round. We're not rounding anywhere yet. We get more accurate of an answer if I plug it straight in like this. Okay, so you get approximately 18.6475 years, which rounds up to 19 years. It takes about 19 years to go from $100 to $149.
I thought you said 8% was good.
It is, but you gotta think about the money. You're only dealing with $100. 8% is real good. And we did this in the last class. Now take $10,000. Take $10,000. You take $10,000 as what you're starting with at 8% and figure out what that would be in 19 years. So y'all do that real quick. So it'd be 10,000 here, E, so type that straight into your calculator. 10,000 E raised to the parentheses, you got open two sets, 0.08, close, open, 19, close, enter, and tell me what you get.
205,824.
Is it? I think it was, somebody in the other class said 45,000. What'd you get?
45,722.
I think that's right. So you're at about $45,000. It depends on how much money you're looking at. I mean, $100 isn't a lot, so it's not going to grow astronomically. But if you have $10,000 up to $45,000, that's pretty good. So the more you have to invest at an 8% return, the better.
You're never going to get 8%. You're lucky to get home.
Correct. Yeah, and if you're in a bank account, a savings account, I mean, you're lucky to get 1 or 2%. The only place you could get 8% right now is if you invest in stock market. But that's risky. I mean, you're not guaranteed 8% in a stock market, right? The only place you're guaranteed money is the bank. But again, you won't get 8% in a bank.